Hi, this is Paula Januszkiewicz. Welcome to Secure Hacks weekly episode. Today we're going to be talking about malware investigation. I would like to show you all the different interesting places where malware resides, what are the symptoms that you actually got infected, because sometimes you don't really know, yes, because malware can hide pretty well. We will search through all of the places where malware can hide and what are the techniques used by malware in order to function. Okay, so let's get started.
Okay guys, so you should see my screen right now. What we see is a Microsoft Network Monitor, and we will perform a little bit of analysis of a situation and environment when there is a malware running, and our job will be to investigate, at the same time learn how to find out a certain type of information in the operating system by using different types of tools, and we will be investigating what this malware does and what kind of components it has. So let's have a look at the Microsoft Network Monitor first, and we're going to start the capture to find out the background for our research. So what we can see over here, it's a communication in between 1010 to 100 into 1010 to 10. We can spot that this communication it's by run DLL 32.exe. So one of the interesting places for malware to be in. But we can see over here this communication was happening at 249.40, and we can also spot that kind of information here as well, that we've got a 249.50, and we can move further and let's see, we've got 250.00. So we can see that that type of traffic, it's happening every 10 seconds. So that's already a little bit weird. Let me stop this traffic and let me get to the web server that we are, as a client, communicating with. So this is our web server right now, and we've got here the regular default website. What is the point? The point is that, well, maybe because it's out there running, maybe we should just stop it and see if the communication still persists. So let's be back to the client and let's find out in the trace if that kind of traffic is still out there. So I'm going to do a new capture and start, and let's see if the communication is still there. So for now we don't see it. For now it's not there. Oops, and it's over there. So we can see still TLS as a form of a communication. So we've got again 251.11, and we've got another one 251.21. So again, that communication is still happening, which is a bit weird because we have stopped the web server, right? Well, not necessarily, because the web server, as we have it, one thing is the service that we are affecting here, but another thing is http.sys, which is accepting traffic anyway. So on the web server, let's run, it's going to be quite of an old school, but why not, NetSh. So we got it, and within the NetSh we will analyze what kind of services, what kind of processes are listening within the certain types of ports, but definitely within the HTTP traffic. So NetSh, and then let's do HTTP show service state. Yep, here we go. So these are the different types of processes that are listening within that particular web server right now. So there's plenty of things, as you see. For the fact that we have stopped IIS, it doesn't really mean anything, because we've got over here as well the remote management, so Windows Remote Management 5985 and stuff like that. And we've got over here something that's kind of weird, which is called pricing. So that is definitely very strange. If we try to get access to this, let's do it. I'm going to do it by using Internet Explorer, and instead of asterisk I'm going to type localhost, and that's kind of interesting for me because there's like absolutely nothing that should be out there because we have stopped our web server. But well, question is, will there be any type of website that is active? And as we see, there is indeed something like that. If I refresh it by pressing F5, this is changing. Well, basically, this is, I can tell you how that part works. This is the very temporary piece of code that is used to encrypt the traffic in between the malware server and malware client. So this is in order to make the whole troubleshooting a little bit more difficult. But that's not what we are focusing right now. What is more interesting for us is to find out what kind of process is actually engaged in this pricing thing. So let's find out. We've got over here request queues, and we've got the process ID 976 that is out there and 4204. So at that stage we can get into even task manager, it's fine. We can go to details, sort by the process ID, and we've got over here the process ID 976, and that's SVC host. Quite an interesting place for malware to be in too. But there is also 4204, and that's even a more interesting place for malware to be in, because that's just like executable that is used and it can be used for running different types of DLLs. So we have found out this one. Now question is how to find more details about it. Well, you can run Process Explorer or Process Hacker. Two options are possible here. I got here Process Hacker. Let's use it as an alternative. Previously we have used Process Explorer. This time we can use this one. And when we search for and by the process ID, here we go, we got it. We can get into properties, and then we can spot in general what are the execution parameters for run DLL32.exe. And we can see that this one is running malware server DLL.dll with the particular method we've got run cc. So this is an export. So basically we can analyze this particular DLL and find out what it does. Okay, so this is good. Now what is interesting at that stage is that let's analyze things a little bit as well on the client side, because we are able to spot a little bit more over here. Here we go. So we can see at that stage within the Microsoft Network Monitor that the process responsible for it was run DLL32.exe, but sometimes this information might not be the one that we rely on. So at that stage what we would do, I'm going to elevate the console to the administrator, and the next stage is that I will use Xperf to analyze in details what kind of processes communicate over the network. So I'm going to run Xperf with the parameter on, and I'm going to define here proc thread, here we go, and I'm going to add on the top of that loader, and I'm going to add on the top of that network trace, and to make it nice and pretty I can specify the buffer size, which is going to be 1024, why not, and then min buffers, and then I will specify 256, that's kind of a standards, and max buffers 256. Now question is, do we have to specify that? Yeah, actually you can skip this part. I just want to show you something nice where we are actually setting up some boundaries so that our log does not go crazy and it has a good performance, and that also sets us the details. What should be, of course, the buffer size where we collect data when we are performing the tracing, and at the very end we will need to specify the max file, and let's say 256 as well, and file mode we will do it circular. So long story short, what you could do, you could even skip the whole thing over here. The only thing you could leave is Xperf on proc thread loader and network trace. This allows us to perform the tracing of what's happening within the network with all the necessary details. So let's do it. So we run Xperf right now, and we just need to wait for the moment, at least 10 seconds, to be able to get that information out. And when we are done, the next thing we do, it's xperf, and then we do stop -d, and we dump this information into network ETL event trace log. So network ETL will contain information about anything that was ever communicating within the network. And if I want to get a little bit of more information for humans, I can convert that network ETL event trace log into the regular, for example, text file. So we're gonna do it within the xperf again, and -i, and we will specify our network ETL, and then we will do -output into network dot txt action dumper, and network txt will contain here information about different types of communication and communication types made, and the processes communicating over the network. Find SDR has plenty of options, yes, but in general what we're going to be using here is the option that allows us to well, ignore different types of characters. So we've got over here, we've got find string, and then we are specifying, of course, different options that we got, and at the very end we will specify the strings and the file name. Yeah, so let's do it. You might be wondering, how do we know which strings we are searching for? Well, you need to know that structure a little bit for sure, but for us it's going to be quite straightforward. Let's do it. So we've got a find string -i, and then we will specify TCP, for example, send, why not? And we will specify it in the network.txt, and that gives us a beautiful output where we can see that indeed run DLL, it's the process name that we've been using over here in order to communicate to 10.10.2.10. So this is this characteristic of the traffic that we could see before, and we've got here also the communication from the 100, yeah, so 10.10 to 100, which is our client. So that also confirms that this is this type of traffic that was happening here, and run DLL indeed was the one engaged in a whole process. Okay guys, so long story short, let's again open a process hacker. I'm going to open it as an administrator, and let's find this process. So run DLL 32 .exe. Let's get into that place. Here we go, this is the one. And what is in our interest, it's to find out, so here we've got the process ID, by the way, 6072. So what is our interest is to find out a little bit more details about what is loaded within that particular executable. And we can see, as previously, that we've got malware client DLL.dll, and we've got run client export. What is quite interesting for us, and I would like to show you a little bit of a deeper analysis, is that when we get to modules, we can spot what kind of interesting DLLs we are actually loading over here. And what is interesting for us, we can just sort this by name. One thing is the malware client, which we can eventually do open file location, and we can copy it and then put it to our analysis folder. Let me do it. So we've got it here, so I'm going to drop it. But what we can also find interesting here, it could be, for example, let me sort by the description maybe. So it could be something like this. So we've got here a temporary file, which is our malware client. Of course, we see that this is malware client, but what we are quite often searching for, it's something that is not digitally signed. So when I sort by the verified signer over here, yes, then I see that there is plenty of things that are not necessarily signed. And we've got this guy. So what we can do as well, we can get into open file location, we can take it, and we can copy it and paste it for the analysis. So long story short, we've got a bunch of files gathered that we are able to analyze. Okay, so let's dig in. Basically, what is also interesting is that it would be great to analyze this malware client DLL. So what can we use for that? For example, we can have a look at the resource hacker. Resource Hacker, it's a quite an old tool that I'm pretty sure you are familiar with if you did a little bit of analysis before. And what we will do? Well, let's have a look and open our malware client DLL. Lovely. And what we can see over here is that there is something binary 105, and then there is this 1045 which starts with MZ. So that is quite interesting because inside we've got MZ, which means, by the way, these are initials of the Polish guy engaged in inventing that type of file, which is Mark Żbikowski, and that's quite nice. And what we will be able to see is that we've got this little 1045, and we can get into actions, and we can do save binary resources. Yeah, so well, because it's MZ, probably it's some kind of a executable, and then we're gonna save it, for example, as data, and then it's gonna be automatically plenty of resources saved, so we can analyze it. And this is this data1 bin that is actually a binary file. What is quite interesting, have a look, because we have saved over here this temporary file, which was one of the modules, and it would be very interesting if we could, at that stage, compare these files. So let's dig into it. So we're gonna go into analysis, and for us it will be great if we could do FC, so for file compare, and we're gonna compare step by step the data1 bin and our another file, which is the one that we have extracted from the modules, and let's find out. And as you see, they are exactly the same, so which confirms at that point that the binary file that we have just extracted within the resource hacker is exactly the same as the one that was running over there. So we've got this. What we can also do, we can analyze that particular binary file in the PE Browse Pro. And PE Browse Pro, it's quite a nice file, a tool that allows us to analyze in details. So I will put here all files, and let's get into here our data1 bin. So we are able here to see in details different types of options where and what this particular file is about. Yeah, so we can spot that. So over here we can see plenty of details about what this particular file is about, and that is well, quite interesting. We can analyze it a little bit, but the only thing that we can see is that we've got one import, that is msquery, and there is just, if we get into details, there's only one function, which is the underscore core DLL main, and that is a confirmation of what we already could see in the process hacker when we were browsing through the TMP file for the run DLL process. This is particularly .NET stuff. So when we analyze and when we see that this is .NET, what we could get to at that stage is actually ALSpy. So let's do it. So within the C drive, we've got our tools over here. So let's get there. We've got our ALSpy, and I'm gonna open it. Okay, so it's opening. So what we will do right now, we're gonna open a binary file that we've got. So let's do all files. So this is the one in ALSpy, because apparently this is .NET code, and we can clearly see, yes, so that this is something that can be decompiled. We can get into, let's get into the malware client lib, and we've got here a method which is quite interesting, which is called checkcc. And over here we're able to spot different types of functions, but basically what's our case is that the method that we are using over here, which is decrypt assembly. That's the one that we are using to decrypt an assembly which will be later on executing on the client computer as a part of this malware. So what is quite interesting is that that particular method, yes, is we can trace it further, but we've got here something that is called the decrypt res, and this is a very interesting function, that the I would say decryption function, that is using well, a couple of algorithms as you see over here, but long story short, we are able to spot that this is using a resource that is called a problem, which is quite interesting because possibly, yes, possibly we will be able here to find a little bit more data, a little bit more options, yes, to be able to get access to it. So that analysis is endless. We could be really doing this for hours, but my goal is to show you what and how deep we can get into analysis. Of course, this not necessarily needs to be possible because the code can be obfuscated, but who knows. What I want to show you as well within this PE Browse Pro is that we can also open here a malware client DLL. So within the PE Browse Pro, we'll be able to disassemble that particular DLL, and that result is going to be a little bit more interesting because we will see here native code. Well, for us right now it's more, I just want to show you if you're curious, but this is also something that will be able to prove us that that particular analysis it can be as deep as you want to, because there is always a lot of things that we can check for. So what we are trying to do right now, we are opening our DLL into PE Browse Pro so that at the very end we're going to be able to disassemble it. So when the DLL is opened, we can get information about exports, and this is something that you already know, run client. This is the export that we could see in the process hacker, and this is our disassembly. So we are able to get into details about what is happening interesting in that particular file. Of course, that analysis is a little bit more difficult. We can see here all the different methods that we've been reviewing. So we've got run web client, malware client lib, and so on. So we've got that. So this is clear for us to spot. We've got as well here a little bit more information that could be, for example, a .NET. So we've got here ICL runtime info, and we can get into a little bit more details. We've got here load and start the .NET runtime. So we've got here some signs that can indicate us CLR create installs, for example, that this is, and definitely MS Core DLL, that this is the .NET code. So at the very beginning we've got the native code, and then later on we've got .NET code. So that analysis, as you see, can be endless, but hopefully I showed you a very nice path how to first trace of what is communicating over the network. That communication over the network can be quite tricky. As well, we played with expert tools. As well, we played with an expert tool, one of the best analysis tools ever, and we have also learned how to have a look inside a DLL, or eventually a binary file, which seems to be also an executable file, both in the native code and as well in the .NET code. So this is a little bit of a guidance for IT pros who are searching for a little bit of more challenges within the malware analysis.
Okay, so that's it. I hope it was interesting. And in order to find more information, go to our website, which is secureacademy.com. Hopefully see you there. Bye.